The constant movement of water through Earth and its atmosphere by evaporation, condensation, and precipitation. Water cycle. The water cycle is the journey water takes as it changes form and moves from the ground to the sky and back again. Imagine you're trying to manage a wardrobe that's always overflowing with clothes, yet you can't seem to find the right outfit when you need it. This scenario is similar to the water cycle, where water continuously moves through its various stages, just like your clothes cycle through different states of being worn, washed, and stored. In both cases, there's a constant flow. Evaporation is like taking clothes out to wear, condensation is like washing and drying them, and precipitation is like putting them back in the wardrobe, ready to be cycled through again. Water that falls to earth in any form, like rain, snow, sleet, or hail. Precipitation. Precipitation is when water from clouds falls to the ground as rain, snow, or ice. Imagine you're at a party with a variety of drinks being served, but you're not sure what you'll end up with in your glass. Just like the uncertainty of which drink you'll receive, precipitation involves different forms of water falling from the sky, such as rain, snow, sleet, or hail. The connection is that just as a party guest might receive any beverage from the selection, the Earth can receive any type of precipitation depending on the atmospheric conditions, with temperature and air pressure acting like the bartender deciding what gets served. The top of liquid changing into a gas. Evaporation. Evaporation is when a liquid turns into a gas, usually from the surface, when heat causes its molecules to move faster and break away. Imagine sitting in a crowded room, and gradually people start leaving one by one, making the room feel less congested. This is similar to how molecules at the surface of a liquid gain enough energy to escape into the air as gas, reducing the overall density of the liquid at the top. Just like people leaving a crowded room makes it less crowded, molecules escaping from the surface of a liquid into the air make the liquid level decrease, illustrating the process of evaporation. The process of a gas changing into a liquid. Condensation. Condensation is when water vapor in the air cools down and turns back into droplets, like on a cold glass. Imagine trying to fit too many clothes into a small suitcase before a trip. As you pack, the clothes get compressed and squeezed tightly to fit into the limited space. Much like gas molecules cool down and come closer together to form a liquid. Just as the clothes change from a loose pile to a compact bundle in the suitcase, gas molecules transition from a freely moving state to a denser liquid form during condensation. A huge body of air with similar temperature and moisture throughout. Air mass. An air mass is a large volume of air in the atmosphere that has uniform temperature and moisture. Imagine opening your closet and finding all your clothes are the same color and fabric, making it easy to decide what to wear. This is similar to how an air mass functions, as it is a large expanse of the atmosphere where the temperature and moisture levels are uniform throughout. Just like your closet full of identical outfits provides consistency and predictability in dressing, an air mass offers a consistent weather pattern over a large area, as it maintains the same temperature and moisture characteristics throughout, much like the uniformity of your clothing. The boundary of a mass of cold air where it slides under a mass of warm air. Cold front. A cold front is when cold air moves in and pushes warm air upward, often causing weather changes like rain or thunderstorms. Imagine you're at a crowded party trying to find a place to sit, but the couches are already filled with people lounging around. Just like how you might slide onto the floor in front of the couch to claim your spot, a cold front does something similar by sliding under a mass of warm air. The crowded couch is like the warm air, already settled in its place, and you are like the cold front, moving in and finding a position underneath the existing warm mass. The boundary where a warm air mass moves over a cold air mass. Warm front. A warm front is when warmer air gradually slides over colder air, bringing gradual weather changes like light rain or milder temperatures. Imagine you're at a crowded concert, trying to make your way to the front where it's warmer and more energetic, but there's a dense crowd in front of you that's standing still. Just like you slowly maneuver through the crowd, a warm air mass gradually moves over a cold air mass at a warm front, trying to take its place. In this analogy, you are the warm air, the crowd is the cold air, and the gradual transition from the back of the concert to the front mirrors how the warm air rises over the cold air, creating a boundary known as a warm front. An instrument that measures air pressure. Barometer. A barometer is a tool used to determine atmospheric pressure, helping forecast weather changes. Imagine you're trying to determine if it's going to rain by feeling the heaviness of the air around you. This is similar to how a barometer works, as it measures the weight or pressure of the air. Just as you might feel the air getting heavier before a storm, a barometer detects changes in air pressure to predict weather patterns, with the air's weight acting as a clue, much like the way your senses perceive the heaviness in the atmosphere. An instrument that measures wind speed. Anemometer. An anemometer is a device used to measure how fast the wind is blowing. Imagine you're trying to gauge how busy a restaurant is just by driving past it. This is similar to how an anemometer measures wind speed by observing how fast the wind causes its cups or blades to spin. Just as the number of cars in the parking lot can help you estimate how crowded the restaurant might be, the speed at which the anemometer's components rotate provides information about the wind's velocity. The weight of the air pressing down on a surface, air pressure. Air pressure is the force exerted by the weight of air molecules on a surface. Imagine you're at a crowded concert, trying to move through a dense crowd to reach the front. Just as each person in the crowd is exerting a force against you, making it difficult to move, air pressure is the weight of air molecules pressing down on a surface. In both situations, the force exerted by each individual, whether a person or an air molecule, accumulates to create significant pressure, making it challenging to move forward, or, in the case of air pressure, to lift against it. The layer of gases that surround the Earth, atmosphere. The atmosphere is a mix of gases like oxygen and nitrogen that surrounds our planet, protecting life and helping regulate temperature. Imagine trying to keep your house warm during a chilly winter's day. Just like how your home's walls and roof trap warmth inside, the Earth's atmosphere acts as an insulating blanket, keeping our planet at a stable temperature. The layers of gases surrounding the Earth, much like the layers of insulation in your home, prevent essential heat from escaping into space, ensuring a livable environment for all life forms. The boundary between two air masses of different temperatures is called an air front. An air front is where two different air masses meet, often causing changes in weather. Imagine you're at a crowded party where half the room is filled with people who love dancing and the other half with people who prefer sitting and chatting. Just like how the dancing enthusiasts and the chatty sitters create a noticeable divide at the party, an air front is the boundary where warm, energetic air masses meet cooler, more stationary ones. In this analogy, the dance floor represents the warm, active air mass. The sitting area symbolizes the cooler comet, calm air mass, and the boundary where they meet is the air front, much like the line dividing the dancers from the sitters. The warming of the Earth when the atmosphere traps heat like a blanket. Greenhouse effect. It is a process where certain gases in Earth's atmosphere trap heat, keeping the planet warmer. Imagine trying to fall asleep on a hot summer night with a thick blanket covering you. Just as that blanket traps your body heat, making you feel warmer, Earth's atmosphere acts like a blanket by trapping the sun's heat. In this analogy, your body is the Earth's surface. The trapped heat is like the sun's radiation, and the blanket represents the gases in our atmosphere, which trap heat and warm the planet, illustrating the greenhouse effect. The amount of water vapor in the air humidity. Humidity is how much moisture is present in the air around us. Imagine trying to fit all your clothes into a suitcase that seems just a little too small. Just like the suitcase has a limit to how many clothes it can hold, the air has a limit to how much water vapor it can contain. Humidity is like the fullness of that suitcase. The more water vapor in the air, the closer it is to being full, just as a suitcase gets heavier and harder to close as you pack more clothes into it. The atmospheric conditions at a specific time and place, like raining and cold. Weather. Weather is the state of the atmosphere at a particular time and place, including temperature, humidity, wind, and precipitation. Imagine standing in front of your closet in the morning, trying to decide what to wear based on the day's plans. It's similar to checking the weather, where you assess what's happening outside, such as rain and cold, to prepare accordingly. Just as you consider the day's events, like a meeting or a casual outing, to choose your outfit, you look at atmospheric conditions like precipitation and temperature to decide if you need a raincoat or a sweater, highlighting how both scenarios involve evaluating current conditions to make practical choices. The average weather conditions of an area over a long period of time. Climate. Climate is what you expect in terms of weather patterns over many years in a specific region. Imagine trying to figure out someone's personality by observing them only on a single day. Just like a person's true character is revealed by their consistent behavior over time rather than by their mood on any given day, the climate of an area is understood by examining its weather patterns over a long period, not just a single day. In this analogy, the single day is like a short-term weather event, while the long-term observation of mood and behavior parallels the study of climate, which requires looking at average weather conditions over many years. A large tropical storm with winds of more than 74 miles per hour. Hurricane. A hurricane is a powerful storm system with strong winds and heavy rain that forms over warm ocean waters. Imagine you're trying to organize a large group of people for a surprise party, but everyone has their own ideas and moves in different directions. This chaos is similar to how a hurricane forms, as warm ocean water fuels the storm, causing individual wind currents to spiral and combine into a powerful system. Just like how the group needs coordination to successfully pull off the party, a hurricane requires these wind currents to align and organize into a cohesive, swirling mass with winds exceeding 74 miles per hour, creating the intense tropical storm. A spinning funnel-shaped column of wind. Tornado. A tornado is a powerful rotating storm that extends from a thunderstorm cloud down to the ground, causing intense wind and damage. Imagine trying to untangle a mess of earphones that have been shoved into a pocket. Just as those earphones twist and turn into a chaotic knot, a tornado forms when differing wind speeds and directions cause air to spiral into a tight rotating column. The tangled earphones represent the swirling winds, with each loop and twist akin to the tornado's spinning funnel shape, both resulting from conflicting forces, creating a spiraling motion.